Hi, good day to all. My name is Ram Chandramurthy. I lead a global practice within the Wipro, uh, and as well as that I'm a practitioner too. I'm going to cover like today what is the trends we are seeing in the database world, how Yugabyte enabling customers to modernize and migrate legacy RDBMS to cloud native distributed database world. I will cover predominantly, so what are the current problems and then how Yugabyte solve the problem. We will cover in subsequent slides. Yeah, I think we are there in this IT industry for more than 3-4 decades. And RDBMS is definitely a popular and the best choice when we try to build solutions on-prem. If you look into that, the most of the popular RDBMS, it works very fine on the on-prem to meet our data requirements with a certain size and with a certain workloads. For example, if I take example about like Oracle as an example, it works fine with up to a couple of terabytes or up to 20, 30 terabytes. But however that, as and when it increases the volumes or it increases the volumes from the read and write consumption apps aspect, it will have a lot of implications on the performance. For example, if a million users try to read and write the data on a single node, it might be work well as we expect. But if you want to increase your user volumes from a million to like 10 millions, then the vertical or a single node based databases may not able to suffice the requirement. In summary, any RDBMS works very well if it can scale horizontal, but vertical scaling will support only a certain workload, a certain storage. So that is a major problem. And when you see the way we used to build applications which are like monolithical architecture, you will have a user interface and user interface will be embedded with respect to business logic. And we build like data access layer. So all these will connect to an active database to provide a particular availability in case if primary goes down, you have a passive database. This works well for a certain workload, for a certain data volumes. But the problem is that if your consumption requirement increases by multi-fold, the vertical boxes cannot scale. You can add up to some GB, you can add additional RAM, but it will come with all limitations. And it needs a lot of manual operations. For example, today you have like 1 terabyte of the storage. You need to increase 1 terabyte to 2 terabyte or 5 terabytes. You need to do a lot of manual work to do that activities. And if you're trying to do any operations, either physical or logical, it all depends on the human. You need to spend a huge amount of the cost. So in a summary, the monolithic architecture will help us to deliver at some use cases with a lot of limitations. If you see here, when we are trying to modernize the app, so monolithical app, we will split into smaller microservices. Means, for example, you have a UI earlier used to do 10 operations. Each operation we used to split into one logical unit, and that logical unit we embed in a particular microservice. Means, for example, if you have 10, 20 programs, the 10 might be split into 200 or 300 microservices based on the function it does, based on operation it does. What the problem with this approach is that the number of connections required to establish for each endpoint of a microservices will take a lot of like hit onto the database. For that, the only option we used to have as adding a lot of read replicas. Means you will have one write and you have a lot of read. For example, because of any reason, your primary array, the write node is down. Then all read replicas need to adjust based on the priorities. Based on priority, the first read replica will be turned into the primary, which is write, and all subsequent priority replicas will continue. But even with this one, a lot of limitations. One is that a single write, the user, whoever initiate the data write operation need to wait a significant time. And read replicas, the synchronization between the write and read is based on the current RDBMS. It will come with a lot of challenges. It cannot scale to support as many microservices. It will add a lot of burden because you need to create as many read replicas and you need to maintain them. And you need to have the downtime. When your primary node is down, then you need to ensure your read replica is up and convert that one to as a main writer node. And siloed databases. So anyone try to modernize either their RDBMS or either these apps using the RDBMS, it comes with a lot of cost rather than achieving the purpose. But however, every customer is thinking in relation to the app modernization, the database modernization. So a database modernization is nothing but bringing operational data into more agile fashion, and it should support the various workloads. It should enable the data scientists, decision makers to read the data on the fly without impacting. So in summary, every customer is looking to modernize their data to bring a lot of value from their operational, transactional nature of the data to make an intelligent decisions. But with the limitations of the RDBMS, what we discussed, how companies like Wipro enabling customers by leveraging distributed SQL, we will cover in subsequent sections. In addition to that, there are many triggers. For example, like a particular company comes with a data center expert. Then they need to make a decision whether they want to buy a new data center or whether they want to go with like a cloud. Again, like there is a capacity need. As I said that maybe a database provision for 1 terabyte, but they might be acquired a new company which needs 10x size. Then it is not possible to extend the current siloed or monolithical databases from 1x to the 10x. It's very expensive and it comes with a lot of problems. And there are many reasons. There are many reasons. So all these will trigger or triggering every enterprise customer think beyond the legacy or RDBMS nature workloads. But how customers will be enabled, like companies like Wipro, to modernize, migrate to the right destination? Many customers are looking as a solution as a cloud. So it could be a public cloud, it could be private cloud. The cloud offers a scale where database size can grow and a database can provide a horizontal scaling. When we say the horizontal scaling, for example, if you have a one node with 64 terabytes as an example, and 64 GB to process your IO operations, and you need to move from 64 terabyte to 6 petabytes. So, but you cannot extend a single node. Every node comes with a certain limit for your RAM, for your storage, for your processing. What we educate the people based on the workload, we will ask them to leverage horizontal workflow. So where people can move from one single node to many nodes. What it does, it enables expand the volumes, support 10x to 100x the read-write request from the consumption aspect, automate a lot of the operations. But how we can enable, how we can migrate? The one is that every customer is looking the new way of storing, how it will optimize their cost. So what we do is that we understand the current spend per core. If they continue the same model on the cloud or private cloud, we will validate those costs with distributed databases such as Yugabyte. First, we will do that. What is the cost and what are the features they will get? Second one is that we will try to build what are the risks associated, how we mitigate, how we ensure it's a zero risk to IT and business organizations. And we bring a lot of innovation through a lot of investments we made to modernize, migrate the databases apps from on-premise to cloud native databases such as Yugabyte. So we are going to cover in subsequent slides. But what are the options they will have in them? So typically, for example, a customer says, I want to exit my data center. Then as a step one, we will recommend them to move their workloads towards to a cloud using IaaS. But they will continue the legacy databases, the legacy apps as a step one, but they will reduce the cost associated with the infra. As a step two or option two, what we recommend, we recommend them to look for that managed services. The managed services could be on-premise or it could be a cloud. So with that options, so what we do typically is that we will try to see that is the current legacy application will enable them to move the current databases with lower cost by eliminating the administration cost. That's what we do. The third one is predominantly the re-architecture, moving away from the current databases and moving to the age-old databases such as RDBMS to distributed SQL. So we'll enable them predominantly look for a open source, look for a cloud native, which provide a vertical scaling, which provide horizontal scaling, which is cheaper and which provide the more features than the on-premise databases. So where we will recommend. The third option is nothing but a database re-architecture. So Yugabyte comes under the third bucket. So wherever that app can be migrated, modernized to an open source database with much lower cost, can be scalable with huge size from the current 1 terabyte to a petabyte or hundreds of petabytes, and can move a single node to multi-node where the number of users, the number of microservices, the app consumption can read the data. So, but how we will enable to achieve these, the cloud modernization, migrating the traditional databases to the cloud native databases. If you see here, before we explain the path, there are the various considerations required by every customer. Will it support, is this database, is this app modernization support microservices? Will it support my serverless architecture? Will it support my containerization apps and databases? Will it support multi-zone, multi-regions, multi-cloud to support the fault tolerance? Will it support distributed database, moving away from a single node to many nodes, and multi-region replications, security, cloud elasticity, and there are the various other considerations every customer is looking. So we have our own the architectural guidelines defined when any customer try to migrate from legacy RDBMS to distributed SQL. And as well as that, we work with the IT and business, the requirement. We try to understand what are the requirements and we map every feature, how those features will be meet by moving the legacy databases, legacy apps to distributed databases such as Yugabyte. Okay, before we explain that the distributed SQL database, just I will take a minute to cover the evaluation of the databases. So we all know that like started with a monolithic databases such as like Oracle, SQL Server, DB2, Sybase. So these does wonders when your workload, your user base is small, where you need to store less capacity of the data. If you need to address a specific NFRs with a relaxed SLAs, if you have a money to spend good amount of time to run the cost, it's good. But the problem is that these databases are slow. These databases may not scale. Then what we observed is that the second set of databases started called in-memory databases, such as Redis, Memcache, and few other databases. These databases try to address the latency problems, I/O problems. For example, if anyone want to read the data very fast, instead of once, for example, if the user wants a particular record to be read, then they used to given a particular where condition and it used to scan the disk and it used to get the data. But those scanning on the data, scanning data on the disk being eliminated with in memory. But in memory does wonders with a certain size, especially for the faster reads. But it does not solve the volumes it needs to store. Today we need to store 1 terabyte. Tomorrow we need to store 100 terabyte. But in-memory databases are not good in volumes. Then the next set of databases started like distributed databases, such as MongoDB and few other databases. These databases are solved the most of the sizing problem because these databases started by saying you move away from storing data into a single node. You can have as many nodes. Every node will act as your data store. Based on your need, you can expand your number of nodes. But the problem with these distributed are mostly NoSQL, means it does not support the standard SQL, which is very popular from business community and IT community. Then we have seen that distributed SQL and unified. When we say distributed SQL, so predominantly these databases support the SQL compliant databases. For example, if an app written or a business logic written by using a Postgres SQL select statements or an insert statement or a DML operations, then these distributed distributed SQL databases will allow you just plug in your app logic without changing the app side to connect to the Postgres compliant database such as Yugabyte. So the unified, multimodal, distributed SQL, these are the new edge and very popular database community where the customer need to spend less amount of time complying to the Postgres SQL, which is again an open source database, and support a multi-model, supports your ACID compliant requirements. Then, what is the Yugabyte? So what we are observing that every customer is looking cloud because it offers lower cost, it offers elasticity, it offers the various features. How Yugabyte is different comparatively other databases, other distributed databases. They are the very two important feature. The one is that it's a 100% open source. What it means, Yugabyte offers predominantly the enterprise edition and an open source. There are no features logged in open source, whereas if you see other product partners, they lock a lot of security, a lot of features in open source by saying that if you need these features, you need to invest money. But Yugabyte has not logged a single feature. Whatever the features a customer gets from Enterprise Edition, all those features the customers will get from 100% features from open source. The second one is that Yugabyte is a multi-model. It supports Postgres compliant databases and it supports Cassandra. Cassandra is the most popular open source, which is based on wider column store. For example, if you need to write a transaction in sub-millisecond latency, there is no option in the world. You have to go to a Cassandra or a wider column store where you write the data. In addition to that, by offering 100% of open source, it's a highly secure and it's a distributed. You can keep adding the new nodes based on your requirement. You can scale up, you can scale down based on your requirement. And it runs on all the clouds. It runs on AWS, it runs on Azure, it runs on GCP. And one of our customers started on-premise, and then they expanded the subsequent nodes on AWS. So in a summary, it is a proven hybrid database. You can deploy, you can start with on-prem. You can see how this Yugabyte works for you, and you can expand towards to a particular cloud, or you can deploy your nodes across the clouds. The another customer started on AWS, the 18 nodes they started on AWS, and they went the additional capacity on the GC. Based on the other business region, it's closer to the Google data center, so they made the decision. And they are the Yugabyte customers, like for example, Kruger, they have invested, and as well as that, they build very complex apps, the transactions of the apps and Kruger and various customers. If you see here, these are the features, how the Yugabyte works. The Yugabyte, as I said that, it's very popular when you try to modernize your apps using microservices. The microservices technology is your choice. The Yugabyte is not like a particular .NET framework or a Java or the various kinds of the frameworks. You can leverage any microservices framework based on your choice. And as well as that, the Yugabyte enable you to scale up based on your requirement and based on your architecture, based on your app. For example, if it's a right to be faster, then go with like Cassandra. If your application is more towards to PostgreSQL compliant, you can go to Postgres. It provides a lot of features beyond what Postgres offers. It provides various features beyond the Cassandra database what it offers. It can deploy on any containerization. It can deploy on a VM. It can deploy on a cloud, the various options. The another very important aspect is that the database is ready to integrate with your DevOps, CI/CD pipelines, low cost per change, zero downtime, patching, upgrade, scaling, all will happen without any downtime. And it's very popular, especially if you want to deploy in multi-geo, multi-region. It supports various kinds of the APIs and a lot of features. So these, whatever you see on this one, these are the very few features we listed down. It provides hundreds of the features. We want to cover one of the largest US-based financial institution where Wipro, Yugabyte, and as well as the customer together. So we worked and we have proven that how legacy database can be replaced with Yugabyte and how it reduces the cost and how it improves the performance, how it works natively on the cloud. If you see the challenges, of the problem, they need a lot of tech to be upgraded, refreshed, to be aligned to the technology. And second one is that there are a lot of like satellite data layers are built where it need, because the reason is that a single database cannot hold entire data. Then they started building various databases, like maybe database one to support maybe group A, database two to support group B, like the various databases they try to create as satellites. It need a huge efforts to manage and to maintain such databases. So how Wipro help? So what we done is that, so we have built our own accelerators. The accelerators are proven for close to 10 years with while we are working with various variants of the Postgres and an open source Cassandra and as well as that the commercial grade of the Cassandra. So what we try to understand, so we try to implement an aggregation layer which is required at the starting point. And then the most of the applications logic written in the PCR that is being modernized to Java Spring Boot. And then we integrated with a Kafka to ingest all the real-time data. There's a lot of like master data it receives from real time. So what we done is that we try to build the right data layer, and we leveraged a lot of like the techniques what Yugabyte offers. We have built data models to leverage it's the right, which is a wider column store, which is a Cassandra supports wider column store, and third normal form supports by your Postgres compliant Yugabyte. So we have built end-to-end solution, and we migrated terabytes of the data without issues to the Yugabyte. So this is one of the big success story for customer. And if you see the another one, this is improve the performance by 20x compared to their like RDBMS, which is based on Oracle. So predominantly, this is also more like they have like they developed using Oracle, using like monolithic apps, labs data. The current the Oracle database filled with 20 terabytes. They have visibility to grow by 100 terabytes in the next 2 years of the time. Like they need to buy the hardware-based solution if they need to store 100 terabytes, which increasing the current cost by 10x. Then customer thought that is there any option which reduce the cost from what they're spending now by adding the data to 100 terabytes. So we understand the problem from customer. One is that their apps to be fast enough to support read and write SLAs. Second one, the volume should grow from 20 terabytes to 100 to 200 terabytes to support their operations in the next 6 to 8 quarters. Then what we done is that we brought Yugabyte, we worked with the enterprise architecture group to get the Yugabyte certified so that the individual projects can start leveraging Yugabyte as a distributed layer, either on-prem or a cloud. Then we build the online servicing layer requirements. We try to map it corresponding the app logic into the microservices architecture, and we map the respective the logic into the Yugabyte. And then we automated entire data, 20 terabytes of data migrated without a single record transactions. And predominantly this customer used like the PostgreSQL compliant database because they want to continue the same architecture. And yeah, so the outcome of the result is that the new system can support 200 terabytes of the data with lower than 1/4 of the cost spent on the 20 terabytes of the data. And the new solution ready on the cloud, it supports multiple available zones, multiple regions, and they started predominantly on-prem with 9 node. They expanded now to 18 node on the cloud. So in a summary, so it's a fantastic experience for us while we implemented very complex real-time ACID compliant the transaction workflow, and we ensured that as a team, Wipro, Yugabyte, and customer together worked on that zero loss to customer and migration, smooth migration with the help of the Wipro accelerators. But how we are able to do, how we can do, because when we are trying to migrate uh, RDBMS databases such as Oracle to distributed databases such as Yugabyte, how we enable? We build a approach which is being adopted on PostgreSQL databases and Cassandra databases. As a Wipro, so far we migrated close to 35,000 Oracle databases to various variants of the Postgres compliant databases, which could be a single node, which could be a distributed database such as Yugabyte. And what we done is that as part of our learnings for more than a decade on open source migrations, we build our accelerators where they can adopt in a factory implementation approach. As part of the end-to-end migrations, we build like the DB assessment. It connects to any RDBMS. It try to understand what kind of the features it used while it is converting, migrating to the target database, what kind of issues it will come. It does, and it will give all the details. Those details will convert into a project plan by saying that you have 2,000 tables, you have the 100 stored procedures, you have the 5 DB links. So it creates that all the information into a technical project plan. And it provides that when a task, what are the tasks are required for the automation areas, what are the tasks are required for the manual work. It does everything in a project plan. And it will prepare and it will provide estimation, approximate estimation by saying that what tasks, what dependencies, and how much time a task will take. All those points it will try to find. That's the first part of the migration. The second part of the migration is converting the left side, which is like Oracle, SQL Server, DB2, Sybase, the data structures to Yugabyte database. So we have various tools. The tools will convert SQL to SQL, NoSQL to SQL, SQL to NoSQL. Based on the data model, based on the use case, it automatically determines and it creates that routines for to migrate the data. Some part of the code objects, it need to continue in the database. Like distributed database also supports stored procedures. But however, that we will make a call whether those code logic should be continued in the database. These code logic should be moved towards to the app. We will make a call and it does. And in addition to that, the accelerator provide to migrate the data, to reconcile the data, to migrate the code object, to reconcile the object. So this end-to-end process being automated while we are moving from your RDBMS to RDBMS. Similar approach we have implemented RDBMS to NoSQL, which is CSQL or maybe the YSQL. So if you see here, this is another approach. So predominantly this approach what we call as re-engineering. So we need to ensure that a specific code objects or a model should go to Postgres compliant data model. Some parts should go to Cassandra. So what we done is that again it's an implemented several places, and we have reusable templates. These will enable you to convert, to migrate with zero risk to a Yugabyte from various databases. If you see here, this is a snippet. So what we do is that we have various kinds of the tools. All these tools comes under a solution framework called the Nimbus. The Wipro investing $1 million to $2 million for the current financial year to build additional accelerators automation framework, which will help customers to modernize or to migrate the commercial databases to open source databases such as Yugabyte. So it covers like, yeah, so we have a cloud studio. Cloud studio will enable all the app specific logic towards to microservices. Nimbus tools will enable all the data platform data without any problem to Yugabyte or other open source distributed databases. It achieves more than 60-80% automation by eliminating all the manual work. So we are part of data analytics within the Wipro. And so as a Wipro data analytics, we have 850 active customers. So more than 30% of the customers are data a data platform customers where we do a lot of like modernization, where we do a lot of like the data modernizing to on-prem or a cloud distributed SQL such as Yugabyte. And we have 2 to 3 million, 2 to 3 billion revenues. Data analytics having close to 28,000 to 29,000 people. And as a data analytics, we exist in Wipro for more than 23 years. And yeah, so you can see this one, our credentials, and we have proven our modernizations, migrations for close to 24, 25 years.